Welcome to Show and Tell. Today we're going to explain machine learning like you are 5. So what is machine learning? It's a form of artificial intelligence that observes patterns and learns from these patterns and then uses what it learns to make predictions. So lots of applications utilize machine learning, ones that we use on a daily basis, like ride-sharing applications. So they use machine learning to determine your wait time, to match you with other people if you're going to use a pool, to determine how much that you need to pay for this ride. Email providers also utilize machine learning for things like detecting spam in your inbox. Thank you for that. And also for organizing your mail into lists. You use Gmail, you have the different lists, exactly. Banking applications use it for mobile check deposits to be able to decipher the handwriting on the check. And lots of different applications use face recognition, such as Facebook. So when you upload a picture of your Aunt Fran, it knows that that's Aunt Fran and can tag her for you, right? So in using all of this, it's really important for us as testers not to dismiss these features as, oh, that's the machine learning feature. I don't have to test it. No. You definitely have to test it. And I want to share with you some ideas on how you might go about doing that and some vulnerabilities that you can look out for. So first thing is you want to decide, what's the scenario? What is it that you want to teach the system? What do you want it to learn? And then you feed data to the system to support that scenario. So you're training the system. And then finally, you give the system a quiz and ask, what did you learn? And make sure that it actually learned the right thing. So we're going to do this right now. The scenario here is going to be, we want the system to be able to identify a grapefruit versus a lemon. All right? So we feed data to the system to support this. Here's 10 pictures of grapefruits, 10 pictures of lemon. We label it as such so that the system knows, okay, this is a grapefruit, this is a lemon. So it's going to observe those patterns and learn something. And then 3, we're going to quiz the system. So I used Scratch block programming for this and asked the system to identify these 2 images. I fed it a grapefruit and also a lemon. Let's see how it did. Bomb, it failed, right? So it thinks that that is a grapefruit, and it thinks that that is a lemon, but why is that? So here's the pictures that we fed to the system, example of the pictures. So up top, that's the grapefruit, bottom, that's the lemon. Here's what we tested the system with. Grapefruit, lemon, see the difference? What's different? Backgrounds are different, right? So all of the pictures that we trained it with had the same background, dark background, light background. So the system didn't learn about the fruit at all. It's not smart like us, right? It's only able to detect a pattern. So if we gave it this whole picture, what it learned is some round thing on a dark background must be a grapefruit, and a round thing on a light background must be a lemon. And therefore it failed. So let's delete everything it learned, which is called models, and train it again. So we feed new images, this time diversifying the set of data that we wanted to learn about so that it can accurately pick up what's the pattern, what's common between all of these pictures. And so we have some dark backgrounds, some light backgrounds, some backgrounds with patterns, and now it's able to say, okay, what's common here is that little round thing in the middle. Test it again, and now, yes, it got it correct, right? So a lot of people think machine learning is this absolute truth, and it can't be wrong. It can be wrong. In fact, I'm going to share some more real-world examples of where machine learning went wrong. Up top is a wolf. Bottom is a husky. And there was a group of people that wanted to train the system to be able to tell the difference between the two. So, of course, fed it lots of images of a wolf, lots of images of huskies, labeled them as such. And the system was actually doing a really good job of being able to detect which was which, until fed it another image of a wolf, and it got it wrong this time. After evaluating what could have possibly gone wrong, it realized that in the new picture that it tested with, the wolf was actually on grass. So what it learned was an animal of this shape on snow is a wolf, and an animal of this shape on grass is a husky. Another one. So a subway station wanted to utilize machine learning to be able to detect when it was crowded so that it could open more doors and help improve the traffic flow. So it took a video of the station when it was crowded and also a video when it was not crowded, put those into images, fed it to the system to train it. And it was working beautifully until one day was actually a holiday. So the station was not busy that day. But the doors still opened, all of the extra doors. So they realized what the system actually learned was about the clock on the wall in those pictures. And at a certain time of the day, it's busy, it opened up at that time. Now, what I showed you were unintentional goof-ups, but you can maliciously trick machine learning as well. So machine learning it doesn't recognize us as the human brain does, right? So if it needed to recognize you, it looks at certain pixels and can say, what's your name? Juan? That's Juan, right? So some researchers from Carnegie Mellon took the pixels of other people and put them on these abstract glasses and put those glasses on its face, and machine learning thought that those people up top were those people at the bottom. So you see how tricky this can get. This can be a security violation. This is really not good. But you know, we have a lot of bad people in the world. So here are a bunch of other misclassifications by machine learning. So we can see here that, yeah, clearly things can go wrong. It's not this great all-knowing system that we pretend that it is. So that's machine learning in a nutshell. I hope you've learned a little bit more about it, but more importantly, learned about some of the vulnerabilities that you can look out for as testers. Thank you.